Hello everyone, welcome to today's Knowledge webinar, Introduction to BobCAM for Rhino V1. Join us for introduction to the BobCAM for Rhino V1 CAM modules, and BobCAM's powerful feature and toolpath technology is now available in Rhino's native design environment, providing more toolpath options and better workflow to create toolpaths, verify programs, and post to CNC equipment. And BobCAM works both in Rhino 6 and 7. A little bit about our presenter. Depoalois is a longtime BobCAD employee with a passion for manufacturing. As the voice of the BobCAD After Dark video series, he has produced over 500 videos, and these are how-to videos on BobCAD. And also Al is active on social communities. He might not have all the answers, but he has a team behind him that does, and this is what we want to hear. And now let me tell you a little bit about where you can find the product on Noveg. Just go to noveg.com and you can search the product. Noveg is changing the way designers purchase 3D software, offering more choices, more freedom, best advice, faster service, and zero headache. Check us out at noveg.com. And today, I think Al, as a treat for us, he'll show you later, there's an image that I uploaded in the handouts. It's a beautiful, what would you say, Al? It's a desktop cover. It's a beautiful...
That sounds about right.
Yes. It's a beautiful image. It will show you, and you can download it by going in the tab that says handouts, and it's all yours for the take. And now let me share our screen. I will make you the presenter so you can get this show on the road. Here it is. Beautiful. So this can be yours right now.
Yes, make sure to download it from the handouts, and thank you so much for the kind introduction. I'm really excited to present the BobCAM for Rhino to the Noveg community, so let's go ahead and get started. All right, CAD-CAM, world leader in powerful and affordable software. So who's CAD-CAM, right? Who's BobCAM? Well, we were founded in 1985 in San Jose, California, and our founder's name is Bob. Bob is an MIT graduate, so yeah, he's a smart guy. And fun fact, Bob from BobCAD CAM was named after Bob, okay? Now, when it comes to software, CAD-CAM software back in the 80s, you know, what did Bob think about CAD-CAM software? And really at the time, CAD-CAM software was very expensive, and Bob made it affordable enough for any shop and powerful enough to have a big impact on any shop that used it. So really the formula for our early success was the combination of having powerful software, but not only that it was powerful, it also had to be affordable. So that way shops of any size could use this. Now, back in the 80s, believe it or not, CAD-CAM software was very, very expensive, and there were very little options for smaller shops, medium shops, or even larger shops to get toolpath and drawing features at a price that was reasonable. So what Bob did is he created a very simple program that was very powerful, and it was affordable, and it became very popular with CNC programmers, makers, anybody running equipment that needed to be programmed with G-code. Okay, as computer technology improved, so did our offerings. And here's a couple of our milestones. In the 80s, we were a DOS program. In the 90s, we were a Windows program. Okay, early 2000, we became feature-based. And it's also when our first CAM plugin was created, and that was our BobCAM for SolidWorks, which later became a gold product. Okay, as time went on, we also developed 5-axis functionality and then also mill turn functionality. Now, in recent events, we were acquired by Harris Computers at the end of 2019, and most recently, we moved to our new office from Clearwater to Tampa, which is where we are today. Now, some things have changed in the market over the last 10, 20, 30 years, but some things have stayed the same, and our formula for success has still stayed the same, keeping software accessible for shops of all sizes. So there's a couple of main points that BobCAD really focuses on with our CAD-CAM products. Number one, we really want to be a low-cost solution provider. The key here is there's lots of shops, small and large, that need to automate and improve the way that they program their equipment. For some shops, just being able to do it. And cost is always a factor, especially with material prices, tooling prices, ever-changing landscapes. So we are a low-cost solution provider. We provide powerful software that's cost-effective and give you a lot of options for upgrades, supports, and training. Okay, support if you need help, or on the product, upgrades, new versions, and maintenance and training how to use the software more effectively. Now, we also focus on fresh toolpath technology. Our development team works with our partners, we assess the market, and we bring the best technology at the best prices for everybody, providing up-to-date, industry-proven current technology to drive your CNC business. Now, another differentiator with us is our ownership options. Over the last couple of years, there's been a lot of changes in the way that software is provided to customers. And we understand our clients want flexibility, whether it's a subscription-based, a license, or an Advantage plan for ongoing support. You guys have options, and we still believe that's very, very important. The last area of focus is really ongoing training. There's a lot of options within this software, or really within all software, and success is based on your ability to learn what those options are and how to use them well. And what we do is we hold weekly free training events for our CAD-CAM products. We know users, they need to learn this stuff, and without the training, it's gonna slow down their success. So we're dedicated to providing ongoing training to speed up the success of our clients. And one of the ways we're doing this is with our weekly free training events. Now, why are we here today? Well, after 36 years, we finally have a plugin for Rhino that runs right inside the native design system, and that's what we're introducing today. This is the BobCAM for Rhino V1. It's a CAM plugin, so it adds right into the Rhino product. It works in 6 and 7, so Rhino 6 and 7 users. These are the CAM modules that we have available currently for the product family. So this is engine lathes, turning centers, slant beds. This is desktop routers, 4x8 routers, vertical machining centers, horizontal machining centers, mill turn machining centers, 2 and 4 axis wire EDM. We also have add-on modules like probing, so you can do in-process checking or pick up your work offset. Our very popular Bob art for converting images into lines and arcs that you can machine. G-code editor for editing G-code, and machine simulation to catch collisions, and full machine kinematics to verify your programs. Now, with BobCAM for Rhino, we're talking about working smarter. We have easy to implement, powerful CAM features that make programming smarter, okay? So, working with your geometry or libraries that we have, we want you to work smarter. And by working smarter, we also want to allow you to work faster, okay? Our CAM software has many powerful features that allow users to reduce programming and cycle times. Things like CAM tree templates, default settings, quick reporting and feedback tools for cycle times or collision checking, feed rate mapping, adaptive toolpaths, and other high-speed options. The final area of focus here really is configuration. As a new shop getting started, your needs are different than a mature shop that's been in the market. And regardless of whether you're just getting started or you've been programming machines for the last 3 decades, you're going to need software, and your needs are going to change. And how we address those changing needs is with our modular system that is configurable for a variety of different applications. So you can get what you need now and be able to add on or upgrade onto higher modules as necessary, okay? The final thing in BobCAM for Rhino, work smarter, work faster. And what we're going to do at this point is get right into the software. So give me just a second to get the Rhino up. And I'm going to start with Lathe, right? The redhead stepchild of CAD-CAM software. So I'm going to start with Lathe, turning, lathe, and let's just kind of get into it. So right now I have a part that's already programmed. I'm right inside a Rhino. And what I want to talk about is our CAM tree. Okay, so any CAM system that you're using likely is going to have some kind of structure to tell the software information about the job, tools that you're using, where the zero is, and this is what we call our CAM tree. BobCAD is a feature-based CAM tree. So let's kind of take a look at this. The first thing that we see here is that there's a job here, okay? So below our CAM tree, CAM defaults, there's a job, and I have an active turning job. Okay, below that turning job, I have a systems default setting. Okay, what you can do is set up different defaults for different machine types or applications. So that way, when you're in the software, common features are going to come right up or defaulted to your preference. Okay. When we look at the BC2X, this is your machine definition. This handles the kinematics of the machine, you know, limits, direction of cut, things like that. As far as specifically with the machine definition, okay, this is your post processor. So this is what formats your code. BobCAD does come in with popular pre-built post processors. We have a library available behind our support site, or if you need a custom post processor built, you can send us a post request form. You fill out the necessary information, we can build one for you, okay? Below this is where we're gonna see our tools. Now, if we right click on tools, you have access to a tool library. Within the tool library, there's different categories of tools. So we have our drills and we have our different lathe, roughing, and finishing tools. It does come pre-installed with a standard tool library. You can quickly add tools just by clicking add and then adjusting the parameters for the tool just by MDI, okay? You can also save out a tool library or import a tool library. So you can have different tool libraries for different machines, okay? If you look into the tool section as well, there's also a tool crib. This is a list of all the active tools that are in the job. You have the ability to save out a tool crib at the end of the job or import a tool crib at the beginning of the job. Okay, the other thing you can do too is you can import tools from the machining cloud. Okay, the Machining Cloud is an online application that stores tooling information from a lot of popular vendors. You can build tool assemblies on the Machining Cloud and import them directly into your tool crib or your tool library. And this really does speed up the management of tools and also the creation of tools, especially with turning when you have boring bars and a variety of other tool insert and holder geometries, okay? All right, the other thing we're going to look at here is verified tool assignment. Verified tool assignment will list out all the tools that are being used in the job and their tool numbers. So if you need to change them prior to posting, you can do so right here. All right, below that we have our stock. Now our stock, depending on what job you're working on, this is generally where you determine the stock size or the stock shape. It's also in turning is where you'll set some clearances and also your origin or your zero for the job, okay? Below that, there is a material library, and then below that, you have your machine setup. So this is your work offset or your zero position, all right? Now, again, BobCAD is a feature-based CAM system. No, that does not mean it automatically programs your part. What it means is within the CAM tree, you're gonna load features. Those features are associated to geometry, okay, or in the facing routine, it will pick up the end of the part. So you have a feature associated to geometry that contains either a single operation or multiple operations. So like on the OD turning, you can see OD turning, we have our selected geometry, and then we have a rough operation and a finish operation. Same thing with the groove feature. We have a groove feature. It's associated to geometry, or we select the geometry for it, and we have an operation there. Okay, so that's a little bit about the structure of the CAM tree here. All right, now, a couple of things we want to get into is how, let's say you're going to load a new feature into the tree. I have facing, OD turning, and grooving set up here. Okay, if I want to load a new feature, I could right click on the machine setup. And then I have a variety of different categories that I can choose from to load in different turning routines like facing, turning, grooving, whole cycles, tap cycles, thread cutoff, stock handling, etc. Okay, another way that you could load a feature within the CAM tree would be to right click on the previous operation and then choose one of those same options. Now you can also take a feature from the CAM tree and copy and paste it. So you can right click and choose copy, and you can right click and choose paste. This will allow you to take a previous feature and its settings and be able to apply it apply it on a different feature of the part, or maybe you're in a different job. Okay, now let's kind of step back for just a second. And we have a job set up, and whether you program the job for the first time or revisiting it, you're generally going to want some information about it or some reporting tools. So let's kind of take a look at some of those tools. Now, I'm a big fan of being able to backplot your toolpath. So you can right click on any operation and choose backplot. This will display your tool and holder, and this way you can animate or click through the toolpath to see what is happening. This is great for checking direction of cut and also visually checking for collisions. There's no collision checking in backplot, but you can see if the tool is where it's not supposed to be. So that's a really good option there, and I use that quite a bit. Some of the other reporting tools, you're going to see these little arrows that are here. These are flyout tools, and what they'll do is show you different information about each of the features, things like a rapid plane or your speeds and feeds. So you can come in here and be able to adjust speeds and feeds, or it will also show you cycle times, and really the options that it will display in reporting is going to be based on where you've selected. Okay, so if we come down here to the rough routine, we can see this is where the spindle speed is and the surface footage for our cutting. So these are really fast tools that you can get in here and find out a lot of information about the job without having to dig deeper. And it's a very common workflow to set up the tool path first and then go back and set your speeds and feeds. But regardless of what you may want to use, you can use it in the ways that make most sense for you. Okay, so reporting tools, we have backplotting, we have our CAM tree flyouts to give you information about each of the features or the items in the CAM tree. Okay, we also have setup sheets here. If we come up to the job, we can generate a setup sheet. There's a number of standard setup sheets that come included, or you can customize them. It's an XML document and ends up posting out as HTML, so in a browser type setup. Okay, and you can customize logos and things like that. All right, now, all of our packages include solid simulations, so you can launch a simulation to be able to visualize the material being removed. There's a ton of tools in here to be able to, do a cross section or render the tool path in different ways, be able to show the difference between a part model and the cut model. So a lot of tools in here, way too much to go over here today, but this is a very robust simulation that does come included with all of our packages. All right. Now, when it comes to turning, there's a lot of different features within the turning software that I think is really important to pay attention to. One of them has to do with our operations stock. So as we process operations, we have a recording of the steps or the material that's been removed. And what you can do is use operation stock kind of as a boundary to better target where material is left over. Now, we pre-calculate one based on the previous operation, but you could also select your own profiles in order to tell the software where material is, okay? Now, when we get in here, one of the main things that I want to talk about with turning specifically, I'm just going to edit one of these features here, is under the feature tab in the machining wizard is this constraint section, which I'm going to talk about in just a second. Let me back up just a moment. All right, so BobCAD as a feature-based, or BobCAM as a feature-based CAM system, what does that mean? We're wizard-driven, number one. So when you right-click on your setup here and you launch a turning routine, it's going to open up a wizard. And then from that wizard, you're going to be able to use an explorer style to get to the different options that you want to. Or you can use a next or previous navigation in order to toggle through all the questions that need to be answered. Okay, so within this wizard, there's a couple of things you're doing. Number one, you're going to select the geometry you want to work with. Okay, number two, you're going to set the strategies or the operations that are going to be applied to that feature. All right, so you're going to see a default strategy section up here at the top. Then you'll see a user defined section. This is one of those productivity tools where you can save standard operations like facing as a user defined category and be able to select it right from here versus using some of the ones that we pre-populated. Now you'll notice there's available operations on the right and current operations on the left. So if you want to add a rough and a finish, you can do so at one time, or if you want to remove an operation, you could do so as well. And again, we're going to just work our way down the list. Me personally, I've used BobCAD and BobCAD CAM products for a number of years. So a lot of times I'm just going to jump away or jump to the areas that I want to adjust. But a lot of times new users like to follow through the next previous method. Again, the value of being a wizard-driven system. Now, there's some other features in here that are noteworthy, not necessarily for Lathe, but this apply to all operations. When you get into different routines where you have multiple operations, if there's a common setting like tolerance or stock to finish, you could apply it to all your operations at one shot, really speeding up your workflow and programming. Okay, so that's a little bit about the wizard. Again, I'm going to focus on three areas here for turning right now. The first one has to do with the face routine here. Okay, under the face routine, or really any of the Lathe features, under the feature tab, you're going to see this section called constraints. So depending on the operation, you're going to have one of three different constraints that you can use. You could use your stock geometry as a constraint, so it only generates toolpath where there's stock, or you can use a custom value here. This is on the facing routine, where you could say, hey, you know, take a couple of passes off the face of the part. Maybe the saw guy didn't really cut a clean cut on the blank, right? Okay, so these constraints are going to control where your toolpath is being generated, and it's one of the things that I wanted to point out real quick. By default, if we have this set to from stock and we try to generate a face routine here, we're going to notice no facing toolpath is generated. Okay, so why is there no facing toolpath? Because the toolpath is being constrained by the stock. There's no stock on the face of the part, so it's not going to cut there. To adjust this, we can say, hey, actually, you know I didn't create any stock on the face of the part, but let's have it take, you know, a 1/4 inch or whatever amount of material off the face by using this custom value here. All right, we can come back in and recompute, and now we can see our toolpath is generated on the face of the part. Okay, again, to backplot, you just right click and choose backplot, and this will plot out your toolpath. All right, if you're going to post this routine, you know, because really the whole point of this stuff is generating code, right? So we're going to create an NC program, and you're going to see it will post up that program based off the post processor we selected. All right, let's go back to the CAM tree. So we're talking about the face feature and constraints. You can use constraints to control where your toolpath is generated or not. Okay, the next one I want to talk about is OD turning. OD turning, ID turning, front face, back face. We can handle all of those different programming scenarios with our turning feature. Again, we've selected our geometry. One of the things that you're going to notice here is there's an undercut in this geometry, but when we look at our toolpath, you can see it's jumping over the undercut. Let's go ahead and edit this operation and look at where that option is. We go back to our feature tab on the Lathe wizard, you're going to notice this undercut section here, and it says remove primary undercut. This is a great way for you to select irregular profiles and remove undercuts that are either along Z or along X just by a click of a button. Again, you do have your constraints. You'll notice for the turning routine, you have from stock, from geometry, or custom. Again, more ways to control where your toolpath is being generated and where it isn't. Okay, now the last area that I wanted to talk about here on turning has to do with extensions. You know, so a lot of times when you're turning down a profile, let's go back to this one here. You know, you're turning down a profile. Sometimes you may want the toolpath to extend further or trim back. You don't want to have to go back and reselect geometry. A really easy way to do this is to go to the feature tab. You have extensions for start and end. I'm going to say, hey, stay a 1/2 inch away from the end of the chain that I selected. I can recompute that. And what we'll see is now the toolpath is moving a ½ inch away from the end of the selected chain. So this is a very useful feature to control where things are cutting, either at the start or at the end, being able to extend it or be able to trim it back. All right, so those are some of the features that I wanted to talk about there. The last one I'm going to get into is grooving here, okay? So I have a groove cycle here. I'm going to just back plot it. You're going to see it's just going to go right down into the center and then away, all right? Like most toolpaths, you're going to have different patterns that you can choose from. So if we go into the groove feature, we select it. So we're going to right click on it and choose edit. All right, we can go into our wizard here. We want to go under patterns. Patterns are going to be the different strategies or different types of strategies that you'll be able to work with. Right now I have it set to a single pass, so it will go right down the center. If I change it to the beginning, it will go to the beginning. If I change it to the end, it will go to the end. Anytime you make a change within the wizard, in order to update it, you have to recompute in order to update those changes. And again, now we can see we moved it to the other side that easily. If we come back in here and we look at our patterns again, I'm just going to choose a zigzag pattern. If you want to work your way back and forth to get down to the groove, you can do so. All right, working its way back and forth to get down to the groove. Or you may want to use more of a standard groove cycle. So we can get in here and look at a standard. And then we have a variety of different options as far as sorting control for center out or skip alternate. We're going to just use standard here. We're going to recompute, and then we're going to see how the toolpath is going to work in a standard method. All right, right now you can see it's going up to the top of the part. Again, this has to do with the constraints that are being utilized with this feature. I'm going to address that in just a minute, but before I do that, if we were trying to groove all the way down here, we would definitely be running into problems. One of the rough routines that we have for grooving cycles like this is multiple depths. You can tell it how far you want it to go each pass. We can recompute this, and then what we're going to see is it's going to work its way punching down at the increment that we told it, working its way down to the bottom. Now, again, some of you are like, well, why is it cutting all the way up here if we've already roughed down this profile? And at the beginning of the operation stock, it knows that there's just material here. Well, again, in order to limit the software by the operation stock, you need to turn that option on. So we'll edit the feature. We'll go to the parameters. We're going to say trim to stock and recompute. And then now we'll see the toolpath staying down to just where the material is. So 3 features you're going to use often on a turning routine would be facing. Again, if you're not generating toolpath on the face of the part, check your constraints. OD turning, you can rough and finish, and a variety of options to control whether it's down cutting or just the verticals or the horizontals. Okay, the takeaway here is you can use trim and extend to control where it starts and finishes. And I think there was another one on that too. Let me get back in here real quick. These are some of your patterns for your finish. So you can do down cutting, just turn the vertical faces, down cutting, just turn the diameters. So anytime you're in any toolpath and hey, I may want to cut this a different way, you want to be looking at patterns, and patterns will give you the different patterns you can utilize for that operation. Okay, the last one here is our grooving routine. Again, we have a variety of different grooving cycles, and you can use operation stock in order to control where that toolpath is being generated. Okay, so that's a quick rundown on turning. If there's any questions you guys have, go ahead and fire away. Otherwise, I'm going to move over to the milling routine.
We have no questions so far, but encourage everybody that this is your time to speak up, ask us anything. Okay, everybody's
no such thing as
yeah.
no such thing as a bad question, right?
Yep,
So
yep.
very good. All right, so let's move on to the next one here. I'm going to go to milling. Okay, now the milling routine, again, this is an introduction. Okay, so these are very simple files. Just covering a few of the toolpath options. We have many toolpath options for milling. This goes all the way up to 5-axis as far as capability, but we're going to look at just some of the basic 2D stuff to begin with. You'll notice the CAM tree for milling looks very similar to the CAM tree for turning. So you have a milling job in here. Okay, that job is connected to some system defaults. That's connected to a machine. This is the machine kinematics. That has your post processor below it. Okay, again, we have our tools. Okay, so we have our list of the different tools that we're using here. We can right click and go to the tool library. And I do want to take a moment just to kind of slow down just real quick on the tool library. So you have all your standard center drill drills, taps, those types of tools for drilling. Under milling, we have end mills. So this would be ball, bull, or just an end mill, a ball end mill, or a bull nose. And these can be set up either as roughing or finishing. You do have chamfer tools, sharp and flat bottoms, corner rounders, thread mills, single point, multi-point, and tapered. V tools, where you can define the flat on the bottom, tapered ball mills, tapered end mills, T cutters, dove mills, lollipop. If you're doing a drag knife, we have drag knife tools. And then in our more advanced products, we have barrel mills. This is new technology that is sweeping the market. These tools offer great performance and can be used in both 3, 4, and 5 axis. And these are all the standard tool types that are available. Now, again, you can save out an entire tool library. So you can build a library, save it, and then you also have the ability to import a library. And then when it comes to creating new tools, you have the ability to just enter the values for them. They'll come up on this tab over here, and you can type everything in. You can assign tool holders. But the big takeaway that I have here is we support custom tool profiles. So if you have form tools, custom profiles, all of those are available. You just draw half the profile and select it, and you're able to use that. Now, just like with the turning, there's a tool crib. Within the tool crib, again, you have all your different categories of tools. It will show the active tools that are in the job. And then if you're on the machining cloud and you've created a tool assembly and you've exported it, you do have the ability to import that tool right into your tool crib using the machining cloud export option. Basically, you create a tool, what am I looking for? Export the tool. It finds it, downloads it. It gives you this zip file. You just select that zip file. You can bring them right in and be able to work with those tools. All right, so that's a little bit about our milling tools here. Now our workpiece would be your solid model or your target, sometimes it's called. So if we were working with solids, we could select our workpiece. In this example, I'm just working off a wireframe right now. It doesn't mean we don't work off of surfaces and solids, we do, but a lot of people work with DXF drawings, and this works really well with DXF and Sketch. And you can just select what you want and be able to work with it. I personally really like this render view. A lot of the developers and other techs here kind of make fun of me for backplotting and render, but I think it looks kind of cool. So anyways, good job, Rhino. All right, so we got our milling job, our machine, our posts, our tools, our workpiece, our stock. Now I want to talk about the stock wizard for just a moment. When we're dealing with milling, you have, I think it's 6 types of stock. Rectangular is a bounding box. Cylindrical is a round cylindrical bound. Wireframe, you could use a sketch in order to define your stock profile. Irregular shapes are in process. You could also use a solid model to define your stock. An STL file, you may run a simulation, save out the STL file and load that back in as your stock or your in-process stock. Or you could use a revolve profile if you've already turned a profile down. Okay, so that's a little bit about the stock definition. I'm pretty sure in this example, I just selected the outside sketch. Now there is a material library in here as well. There's over 6,000 materials that are in here. You can customize your own, make your own groups, define different tools, different features, different operation feeds and speeds. So there's a lot that you can do in here in order to load speeds and feeds for different cutters. Again, your setup here, this is your work offset, your G54. Even though this is a single setup example, but you have the ability you have the ability to load in multiple setups. So you could be in 54, 55, 56. Any orientation, you can pick a setup and choose 3 points to define it, or use a coordinate system and you can define that setup in any orientation on your part. Now milling works the same way that turning did as far as features. So you have a feature, it's associated with geometry and contains operations, okay, drilling. So we have a drilling feature associated to geometry and it contains 2 operations. Okay, here's a profile. This one's just a rough profile. This one here, this is a pocket, okay? So very, very common. Now you'll notice that you can expand these. So you can make them bigger or smaller. If you right click on your setup here, you can choose blank and unblank and be able to hide all your toolpaths. This is my preferred method, so that way I can isolate and only look at one at a time. Again, you can go to any operation and be able to backplot it. So you right click and choose backplot, be able to see exactly what it's going to do before you go. If you're done with all the operations in the tree and you want to post it, you can come up here, create NC code, and that will write all the code. All right. Again, we talked about reporting tools and a variety of different reporting tools. So again, you have backplot here, you have solid simulation. Again, you could do a setup sheet. I don't think I showed the other one, but you could just, there's a variety of standard setup sheets that are available here. Let me just drag this over. You can customize what the logo is. This is all XML and comes out as HTML, right? So this will give you all the information about the job. This is really cool because a lot of times you have to type this information down. So this can just pull it from your job tree. And the other thing to notice is you can see how it's got the perspective window. So whatever orientation the model is in the perspective window is what will be populated on your setup sheet. Okay, now again, solid simulation comes standard with all of our modules, so we can load this up. Actually, let me close that. Let's go to a single window. Let's launch simulation. Okay, so in this example, it is showing machine simulation. Okay, so machine simulation is an option in the software, generally recommended for 4-axis or greater. This way you can see the different machine components. One of the things you'll notice is my part is located in the center of our table. So when you're dealing with machine simulation, you have shifts that you can use to be able to move the part around. What I wanted to focus on really was just some of the simulation tools, so you can backplot and simulate. Now, in this case, I have the table set up as a collision checking group. So it notices that the tool is running into the table, clearly because it was setting inside of the table. And it asks us whether we want to continue or stop. I'm going to just say don't show again and let it go through and machine it through our table, but that's why it's showing up in red. Now, this is important because if you have collisions with your workpiece, with your fixture, with your machine components, these are things that you want to know about before they happen, and we have simulation tools to help you with that. Again, it's going to show the material removed, and then there's a variety of different tools that you can use to render the tool path in different ways, be able to check for deviation if there's material. Well, I don't have a solid, but if there's material left over, you'd be able to check for deviation, and a variety of other simulation tools. So I definitely recommend you spend some time in there. One of the things that I personally do though, there's a lot of options here, so I turn them all off. Like you can see as I add them, see how they stack on this list down here. I like to just work with one at a time. So, you know, learn about these options here and then move on to the next one. But again, simulation comes standard and lots of options in there. Okay, so we talked about backplotting, we talked about setup sheets, CAM tree flyouts, and solid simulation. Now, let's get into some milling, right? Okay, so let's go to a perspective view here, and we'll look at our facing routine. Now, one of the things that's really nice about the facing routine, you'll notice that I don't have any geometry selected here. What it will do is use your stock boundary as your facing geometry boundary. So you don't have to select the stock boundary for your facing, it will detect that automatically. Now, if you have your workpiece defined, it will even figure out the depth for you. Again, I'm gonna right click and backplot on this. So just scroll out, we can see we have a standard zigzag facing routine here. Let's go ahead and make some changes to this. So we're gonna right click and edit. Okay, we can go to patterns. So you have a number of different patterns that you can utilize. So if we want to cut in a single direction, we could turn that pattern on. And then if we want to choose which corner we're going to start from, we can do so very easily. To update the toolpath, we just hit compute. And then we can see that this is now cutting a single direction starting from the right-hand corner and working its way over. So this is how easy and fast it is to make changes and updates to your toolpath. All right, if we come in here and we look at our drilling routine, you can see we have a spot drill and we have a drill. If we edit our drilling routine and we go under the spot, you can see you can do a single peck or a single depth or a peck. So this is like a G81 versus G83. You can use pecking cycles on pretty much all the hole making features. Same thing with the drill here. Here's information about the drill, speeds and feeds. We can go to the parameter and be able to set this to a peck routine. Okay, so a little bit about that. Okay, let's move on to the next one here. This is profiles. It's very, very common to work with profiles. In this example, I have this doing contour ramping. This allows you to ramp down as you cut. I use this in all kinds of 2D and 3D routines, ramping around profiles to remove materials, clearing out bosses, a lot of different options in here. Let's go back to our profile and edit. Now this one is under patterns, and you notice there's a standard profile, which will just follow the shape, contour ramping, which will allow you to ramp down as you go, and side roughing, which allows you to take multiple steps to work into material. Very common features here. Now, as far as compensation for profiles, you can have BobCAD compensate for the cutter, or you can load G41, G42, either together or separate, depending on the style of offsetting that you and your shop uses best. To adjust leads, you can just come down to the lead setting and use independent lead in and lead out settings. And if you're working, let's do like parallel, and I'll set this one to parallel. You can have it start off the part and finish off the part with a parallel type toolpath. All right, let's just go back to this one here and we'll finish. Now, the last one under 2D features here is going to be this pocket routine. All right, in this case, I've selected a spiral pocket for circles. So it's going to start in the center and spiral its way out. But we have multiple pocket patterns you can choose from. And again, just like I've done with all the other features, if you want to edit the settings, you just right click, edit. You can come to patterns, and then you can choose from the different patterns that you'd want to work with. Again, a really useful feature here as well is being able to take an operation and copy it and paste it. You could use the same depth values, but now you can go in and select a profile that you may want to use in a different area, maybe adjust the depth, okay, and recompute. And then now you have those same settings and those same speeds and feeds, the tool that you use. And again, being able to copy and paste your features or even your operations is very useful. Let me show you what I mean. I could copy this operation, I can paste it, I can come in here and edit, and maybe I want to iterate, or what might a different pattern look like. So maybe I'll go to adaptive, right? And then I can use all my same settings, but just apply a different pattern to see what it looks like. Now, one topic I want to talk about on this one real quick, this has to do with open pocketing. I'm just working with a sketch right now. Open pocketing with sketches, you're going to have to change the open area to a dotted line. If it's all solid lines, you can see how the pocketing toolpath is staying inside of the boundary. But if I select this edge here and change this to dotted, dash dot, okay. All right, so now this is a dotted line. And then let's select to update the change. So you can see that selected. All right, and we go to this one and we recompute. You're gonna see now it's gonna start outside of the dotted area and work its way in. This is an advanced pocket, commonly known as open pocketing, and it does support outside to in or inside to out. So very common for first stop to clear the stock into irregular bosses and things like that. All right, now I talked about saving time. I talked about working smarter, and probably one of the best features that we have for this, for similar projects and part families, would be being able to capture this entire CAM tree and be able to use it again on a future project. Your work offset, your zero, your tools, your speeds and feeds, all the different settings that are in here, you want to apply it on a new project. So let's take a look at how that looks. I'm going to open a DXF file from scratch. So we'll go to here, and we're going to do turning to begin with. So typically when you open up a file or you've drawn a file, you're going to have some geometry on the screen. And you'll notice in the CAM tree here, there's nothing in the CAM tree. This is a typical starting point for a job, is you have to kind of build the job as you go. So you would, right click, add a new job. You're going to pick the job type. There's milling, turning, mill, turn, or wire. These are for different types of applications. In this case, we're looking at turning. You would come in and pick the machine. These are some of the machines that come included with the software, okay? System defaults, if you have certain defaults you want to run, you can pick that there. Your next step is to run the stock wizard. We don't have a workpiece, so we're going to skip it. And then we're going to come in here and start, setting where the 0 is and then adjusting the size of the stock. I think this is 3 and this is 6. Okay, so we can define some of the stock. We can define the coordinate system, some of the clearances. Okay, so that kind of gets the start of the job done. And then from here, you got to start loading in operations. So again, in our case, end facing, so we'd have to load one of these, answer all those questions. Then we would load, our turning routine, answer all those questions, and then load our grooving routine and answer all those questions. So you can start a job from scratch at any time, but if you could utilize tools in settings you've already set up, wouldn't that save you time? Our customers think so, which is why we created these job tree templates. Once you program the job, you can right click and be able to save that job as a template. And then when you go to create a new job, create new job from template. Choose the type of job and then choose the template you have set up. So I have one set up right here. So we're going to say turning 1, we'll say okay. Now you'll notice it brings in that entire CAM tree there, has the same machine, has the same posts, has all the same tools, has the same stock, and it has all of our operations. What it doesn't have is the association. There's no geometry selected. For the facing routine, we'll compute it, and we're able to use those settings that we had. For the turning routine, we want to go in and select what we want to work with. So I'm just going to window pick this geometry here, and we'll say okay. And then I can come in and compute our rough, and then compute our finish. Okay, so we faced it, we turned it. The last one we want to do here is groove. So again, I'm going to select the edges of the groove here that I want to work with. We'll choose okay and compute. And you can see the same job that we had set up for that turning routine. We can reuse those settings and apply it to future jobs, really speeding up your programming. Let's take a look at the milling routine now. So we'll open this one. We're going to go to milling and we'll say okay. Again, it's very common when you first open a job or you start working with your power file, your CAM tree, there's nothing set up. Again, you can create the job from scratch by creating a new job, picking the job type, and just running through the Q&A here. Like, okay, so in this case, this is the bounding box. This is a good example. This is the bounding box here. And we can see how it's picking up all of the sketches that are on the screen, even this open area that I don't really want. So if I want to control it to an area, I could say wireframe and select this outside profile here as my stock, calculate, and now you can see how it's just using that sketch to control the stock size. And then as far as the XY, as far as the Z, I can come in with the height and be able to adjust that. And if we're in a different orientation, I could do that as well. All right, so just kind of a quick run through on that one. All right, so we got the stock set up. Now we're setting our 0 up. I'm just using top center here. Let me go to a different orientation and perspective. You can see we put all these points on the screen. So if you wanted to click a different position, like this back corner here, you could select that back corner as your, maybe I need to grab it from here. There's a, you can pick that position as your 0. I think there's a filter and option, like a filter and option of that I have turned on that's limiting me from picking that point. Okay, so, but yes, you'd be able to use these point locations in order to define your 0, either at the top, the bottom, the left, or the right. Okay, or any position. And you'll also notice that there's these X direction, Y direction, and Z direction toggles. So once you have a location picked, you have the ability to toggle the direction of Z or X in order to adjust that coordinate system. All right, let me actually just click OK on this. All right, so we have the job built out now. We have our zeros set up. We're gonna, typically we would start loading in different machining features. Okay, so, you know, you might come in and say mill face, and then answer the questions about the facing routine. You know, come in and load your drill cycle. So you're gonna say, I'm gonna drill, and then come in here and answer the questions about the drilling. You know, then we have some a profile in here. So again, you're going to repeat that process. If you could preload a CAM tree with a bunch of standard features, that could be really beneficial. And we feel it's one of the time-saving tools that we have for shops of all sizes. So let's take a look at what that looks like. Let me delete this here. And again, I'm just going to create a new job from template. I'm going to choose the milling one job. We're going to say OK. And you can see this entire CAM tree was brought in. Our stock is the same. Our zero is the same. All of our machining features are here. They're just not associated with any geometry. Okay, so again, for the facing routine, we can recompute and be able to face off our geometry here. Now this one, we may want to have it run through the recalculate so it can find the boundary. Let's see here. Okay, there you go. So I had to run through it to recalculate to find the boundary, but that's the facing routine. The drilling routine, again, I'm just picking the holes, the hole locations that I want to work with. Looks good. Okay, compute on this one, compute on that one. So now we're drilling the holes. Our profile, again, we want to select the profile we want to work with here. So let me zoom in a little bit. I'm just using a window pick. I know there's a ton of selecting tools that you can use within the Rhino products. So you can utilize a variety of different selection tools and workflow there. But again, this is the ramp routine to ramp its way down to the bottom. And then the last one would be the pockets. So we could select the pockets we want to work with. All right, and be able to compute. And now we have our pockets. So again, being able to use templates is a fast and easy way to reuse settings, and because it's all in the details, depth of cut, width of cut, stock for finish, speeds and feeds, you know, the tooling that you're using, the zero position, your initial stock prep. These are things that vary from shop to shop. If you can come up with standard workflows and procedures, it can really speed things up for you. In the past, you know, maybe your CAM system held you down from that. You know, moving forward, BobCAM for Rhino is providing these tools for you so you can work smarter, you can work faster, you can get more jobs out the door. And this is a product family that will scale with you as your business needs scale. So as you grow into 4 or 5 axis, you'll have that capability. Now, there are just a few things that I want to wrap up before we'll open to live questions. We have just a couple minutes left here. Huge features, right? Okay, so you have this job tree set up and you programmed one of these, right? What if you want to make copies of them? All right, what if there's multiples that you want to make, either out of a strip of material or out of a sheet of material? You can go to your CAM tree, your machine setup here, down to additional functions, and use toolpath patterns. Toolpath patterns are a way, commonly known as, in other systems, they might call it a transform, right? But what you're doing is you program one and then you can make copies either as an array, as a translate, a rotate, or by point location. So this is a very useful feature to program one feature on your part and then be able to make copies. Now, there's another way that you can make copies, which is a work offset pattern. So if we right click on the setup here and we go to work offset pattern, this dialog looks a little bit different. There's a lot of things that are on the screen here, but most of which has to do with rendering the work offset, you know, showing it in simulation so you can verify either your fixture or your part and be able to check for collisions. But what this particular one does is it will create copies in different work offsets. So let's take a look at this. We're going to go additional functions and we'll say add toolpath pattern. We're going to do an array. We're going to say an X, they're 10 inches apart, and we want 2 copies. And you'll notice how that makes 2 copies of the toolpath. When I post this, you'll notice that there's one work offset called, and then it's just repeating all these different operations in the same work offset. Okay, that's the key takeaway here. Toolpath patterns are in the same work offset. What if you want them in different work offsets? Well, let's get rid of our toolpath pattern. And that's where we're going to do work offset pattern. All right, we're going to do a similar thing. We're going to say translate. We're going to say they're 10 inches away, 2 copies. All right, there's a bunch of options in here as far as what's displayed when it's patterned. We're going to just do generate copies. You're going to say okay. All right, I'm not seeing anything on the screen here, but when we post this, we're going to see 54, 55, 56 for the first tool. 54, 55, 56 for the second tool. So that's a huge tool to speed up programming, especially when you go from, you know, first article to production, you want to make copies. Now, there are some different options in here. I'm not going to get too technical with the posts, but you can post toolpath patterns with subroutines, so that way you have one main program that's patterned out within the different work offsets. And again, a big feature. The last one that I have for you here is probing. It's a new module that we've added to the software. Again, if you right click on the machine setup, you're going to see the probing option. There's three main things probing does. 1, before cutting, 2, during cutting, or 3, after cutting. Okay, so 3 things you could do as a high level. Before cutting, you might be doing things like touching off your tool, so contact or non-contact tool setters. You can set up all your touch-off routines right from within here. Okay, the other thing that you have here has to do with the different types of, again, different options of whether you're dealing with a hard stop or whether you're using lights in order to do it, okay, or laser, should I say. Now, the other thing you have is like measuring cycles. So with your measuring cycles, you're going to have a variety of different routines. You could pick up just an X location, a Y location, a Z, a web, a pocket. These are all standard Renishaw probing cycles. So in order to use these cycles, you do have to have the cycles available on the control, like whether it's a Haas or, you know, Blum. I mean, there's a variety of different ones that are out there, but probing has become more and more popular. We recently, probably within the last 12 months, we released a probing with our standalone package to begin with, and we've had great success with it. Guys really like it because a lot of people are MDI, they're manually programming their probe cycles, and you always see those pictures of, you know, 3 days since I broke the probe, right? Well, the same reason why you use CAD-CAM or CAM software to program your parts versus writing everything out by hand is the same reason why you'd use the probing module. So you can simulate it, you could use your geometry, you can easily make adjustments. I would say probing, for the most part, some of the functions for after machining, where you're measuring, or if you want to measure and update your work offset, or your, I'm sorry, not your work offset, your diameter offset, you do have to understand a little bit about the variables that you'll be setting and whatnot. But probing is available as well, and that really is my close at this point. Again, I really appreciate everybody taking a moment to spend some time with us. The takeaway is powerful, easy to use, affordable CAD-CAM for everybody, and I challenge you, right, to you know, try it, download a demo, take it for a spin. If you have questions, you have comments, you need some help, our teams are here to help you. And again, I really appreciate you spending some time with us here today, and maybe I'll get to see you again either on a YouTube video or some of the different machining boards that I'm frequent on.
Thank you all. We have a couple of questions actually. So how would you program a turning job like a groove spiral cut?
Okay, so like threading, if you're on a turning job and you have a groove spiral path, if it's a custom form or something like that, that may be a little more difficult. Generally speaking, if you're going to get into like a thread or some kind of spiral, we're going to use like a threading cycle. Okay, so if you're in here, let me let's look at this real quick. That's right off the top of my head, that's how I would approach it. I wouldn't necessarily do a groove, because a groove is going to be like a punch down or a zigzag or a single position. But if you come in here to your thread cycle, it's got to get the stock set up here real quick. So if you come in here to your thread cycle, so you can do threading. So you have lay down or top notch style. These are the standard thread tools, but that's how I would approach it. if we're talking about a more contoured surface, like a journal or something like that, I don't know on a lathe specifically. What I would do off the top of my head is look at some of the threading cycles here and whether you could utilize that for that operation. If that makes sense.
Thanks, and yeah, I hope that's what they were asking. And can you show an example of your adaptive toolpaths?
Great, yeah. So we have 2 through 5 axis adaptive toolpaths. So if we go back to, let's see here. Okay. So if we look at this section here, this is what I'll use for the adaptive. All right, so again, I'm going to copy this feature and then I'm going to paste it so I can use all the same settings. I'll come in and select the boundary that I want to work with, which is right here. All right, I can edit the operation pattern and I'll go to adaptive. So this is a tricordial style routine. I can adjust my step over by percentage. The minimum curvature radius is the smallest radius that it will generate. So you can make this number bigger to keep the tool out of smaller areas, or you can make it smaller to have it go inside there. If you're coming back behind a tool, you can do rest roughing as well. So you can go back and target the material left behind. We'll leave this at 10%, use the adaptive toolpaths and compute this. And you can see this is that, oh, I'm sorry, go to this view here. So you can see this is that tricordial style. The tool comes down to the center. Actually, let me blank the rest of these out. Let me blank the stock, and we'll just look at this one. So you can see the tool comes down, it spirals its way out, and then it uses this tricordial motion to work its way into the corners. Now again, kind of like I was talking about that minimum curvature radius, so you can see how the size of these radiuses that are in there, if we get in here and we make this number bigger, let's say something like that, you'll see how that it will use larger, that's the largest, or I'm sorry, the smallest radius that it can get in there, and then that way it limits where it's cutting. I'm sorry, wrong menu there. So that's an example of a 2D pocket. In our mill professional, we call it advanced roughing, and you can use this same strategy for 3D machining with step reduction, minimum curvature radius, detect flatlands, operation stock. So that's just a quick adaptive toolpath there in some of the settings. So hopefully that answers that.
Thanks, Al. And a final question. Can you mill a 3D surface with multiple diameter roughing tools with BobCAM calculating whatever stock material is left from the previous larger diameter end mill?
Yes, that's actually a great question, and there's a lot of ways that you can attack that. If we go into 3D here, and we look at our advanced rough, and one thing I want to take away, I started with turning and how you can have a feature in operations, then I did 2D milling and I showed features and operations. 3D is the same way. You have a feature in operations. These are all of the available 3D operations under the mill professional. This one toolpath here is a premium, but the rest of them are all under the mill professional software. We're talking about the advanced rough. What he wants to do is come in with a larger tool, whatever size, and rough out your material. So you could do an advanced roughing routine, right? Then what he wants to do is come back with another one. So what you can do is just load another operation there. Okay, this one, maybe it's a 750 cutter. You're gonna stage down, right? So when you come into your parameter, or let me see, options here, I could say rest roughing. So I have one operation with a 1-inch cutter, one operation with a 750. What I can do is use the previous tool diameter. I'm not sure why it's saying it's a 1/2 inch there, but you can use the previous tool diameter. You can come in and, or maybe I typed it as a 1/2 inch. You can come in and tell it what the previous tool diameter is, and then there's some different options in here that you can use for, not like whisper cuts, detect stock thicker than, so you're not targeting material that doesn't need to be cut, previous allowance, your offset, whether you want to leave stock on the wall and the floor or just a global. Okay, so we did 1, we did 2. If you wanted to do another one and stage it down again, you could just load another operation. And as you continue to stage down under this option, you know, that one we don't have any rest roughing, right? Okay, this one you could say, all right, rest roughing from the previous operation. And then this one, you could say rest roughing from the previous operation. So you can stage it down. That's one way to progressively do it. And kind of like what I talked about as far as saving a feature, you can go through and set this up one time, be able to save it as a feature, so that way it knows what the stage down is. The other way to do it, this is kind of an automatic method where it does a calculation based on the tool information to find the leftover material, which it does a pretty decent job with that. But if you want more control, more targeted control in your staging down, that's where you're going to see this operation stock. So you have operation stock, and operation stock. So you can use that operation stock. Essentially, you're giving it the stock geometry that you want it to use as a 3D boundary, okay? And you can stage it down for each one of your roughing routines. Now, where do you get that in-process stock from? One way to do it would be to model it simply. Another way to do it is to run a simulation and then save out the in-process stock. Okay, I didn't really get into that too much. I did talk about simulation a little bit. If you get over here to this Cut Sim tab, which is this one right here, all right, under here it says save stock. So after you run the simulation, you can save your stock out and be able to load that back in as your operation stock. Okay, so if we close this, okay, over here where it says operation stock, you can choose reselect, and you could either pick a model from the screen or you can grab an STL file, which is what the simulation would give you. So either you do it by previous tool information and create multiple operations within that feature, or you can use a series of calculated in-process stocks from simulation and load them in as your operation stock, or you could just draw some simple geometry that represents it and select that as your operation stock.
And great. We also have a comment from Matt about the Spark Group question. So he was talking about using a rotary axis on a 3D router to create a non-symmetrical cylinder, like a sculptural guardrail post. What are you up to, Matt?
We have some amazing tools for that. That's actually a great question. So, you know, this is an intro, and I focused on some of the basics like turning and milling. I didn't really get into a lot of the 3D milling, where I believe a lot of our powerhouse functions are, especially as we continue to move up the line. When we're talking about 4-axis, our 4-axis standard package would offer indexing, wrapping, and rotary. And then our 4-axis advance package, okay, 4-axis Pro, would include all of that plus surface-based toolpaths. Now, if you're dealing with a bus or a post or some other irregular, like a furniture leg chair or a furniture leg to a chair, saying that weird, but any of those scenarios would work well. Now, under the rotary here, this is probably one of the more common toolpaths people use, which will either run around or run along. Again, you take your model, draw it in 3D, and then you can apply your rotary toolpath. You can use rotary for roughing, semi-finishing, and finishing. As you step up in our functionality, if you go to a higher level of 4-axis, you can get this one here, which is 4-axis rotary advanced rough and 4-axis rotary advanced finish. This is Z-level rough meets 4-axis. This is Z-level finish meets 4-axis. Instead of your DOC being a depth of cut from the top of your part down, it's a radial step down. And what I really like about these tool paths is they're super quick to set up and they're driven off the stock model. So if your pockets are a little bit deeper, this is the way that I would go for that kind of stuff. If it's more less irregular, the more irregular it gets, these ones are much better. The less irregular standard radial will work really well. 2 other areas I want to show you there is additional function index system, add index. You use index systems to align tool orientation, and you can select a face or a coordinate system for that. Anything below that index system would be mapped to the rotation, right? So you index it to a position and then you machine from there. So you can load any of your drilling 2 or 3 axis from an index system, all right? The other one we talked about was rotary. So again, you have your standard 4-axis rotary, which I'll get one going here. So you can either cut along, you can cut it around, you could do a zigzag, or you could do a spiral. You have your interval of cut, where it starts cutting, where it ends cutting, adaptive step over, so you can more shallow faces, you can add additional tool paths there. You can see there's roughing routines in order to step it down. Again, really it's just a matter of getting familiar with the options within the feature and then just turning them on or off. Again, one of the reasons why our ongoing training is so helpful to speed up success, so that you can watch like a T1 2D milling or a T1 3D milling type class and really get up to speed on this quickly. But yeah, so this is your rotary and some of the different options in rotary. The last one that I wanted to show is wrapping groups, which are also really popular. Within a wrapping group, you basically set up the diameter that you want to wrap to, and then everything that is child to a wrapping group would be wrapped to this diameter. Rotary would be based off of your 3D solid, and index systems is really just clocking the part, or aligning Z with the part, and then being able to machine child to that index system. So if I was making a bus or some other furniture leg on a rotary on a router, I would be, most of the time I like to do index machining to rough it, because 2-axis is faster than 3-axis, 3-axis is faster than 4-axis, 4-axis is faster than 5-axis, right? So what I like to do is just index, rough in 3-axis, rotate the part 180 degrees, which would be your next index, rough in 3-axis, and then come back with a rotary tool path, and that should be pretty good. If there's a lot of undercuts and a lot of irregularities, you may use additional surfaces or check surfaces to help control where the tool path would go. So hopefully that answers that well.
Thank you so much, Al. That was so helpful. Wow, what a great demo. And I think you just scratched the surface and people can get a better idea of what's underneath all the capabilities of these modules. I unfortunately have to take the screen back, and I want to show everybody where they can get the BobCAM Lathe for Rhino, and go to noveg.com, give us a call. We're happy to talk to you, and and also, Noveg is where you can find Rhino and upgrade if you haven't done it already. And thank you so much, Al. I want to thank you again for your demo today. It's been awesome. And I think we're going to have a second launch soon. Stay tuned. And we're very excited to have you on board. Thank
Yes,
you
thank you
again.
so much thank you for having us. We have lots of really awesome things that we're going to bring to the NoVeg community. This is just an intro of some of our basic packages. I hope that we get to show off some of the really cool stuff, the 5-axis simultaneous, as timeline goes by. But again, anytime you're ready for the next one, we're ready for you. And thank you so much. I really appreciate it. Great thing.
Can't wait. We'll get the popcorn ready. Bye bye, everybody. Have a great rest of the day.
Bye now.